Alright guys, so this next video I'm going to show you in simple terms how we're going to find the antiderivative. Okay? Now what we're going to do in the beginning here is just to get it through reasoning. We're just going to kind of think about it and say, well, obviously it's the antiderivative, which is the integral, therefore it had to kind of come from doing the opposite of the derivative, and we're going to kind of figure that out. Okay? So here, just follow with me. I'll show you a couple of examples. Here I've got x to the third. Now the x to the third had to have come from what? The derivative of what would give you x to the third? Now most of you will say, well, of course it's x to the fourth. Okay, sure. So if we say that this is y, then the antiderivative could possibly be x to the fourth. But watch what happens when I go dy dx. Well, I don't get x to the third, I get 4x to the third, right? And so what I want is to not end up with 4x to the third, I want to end up with x to the third. So what else needs to be here with the x to the fourth so that when I bring that 4 in front, that coefficient goes away? Now the answer to that, of course, is that you need a 1/4 in front, right? Because the 1/4 in front will stay as a constant. When you bring the 4 in front, it'll be 4 times 1/4, which will effectively cancel out, leaving you then with x to the third. And so in the end, the antiderivative needs to be 1/4 x to the fourth. And if you were to take the derivative of this, you would notice that bring the 4 in front, you end up with just x to the third. Does that make sense? I hope so. Just in case, we'll try a couple more in different situations, all right? Let's look at e to the 2x. All right, so we've got e to the 2x. Now, we know with e that e comes from e to the derivative of e to the x is e to the x. So what we're going to say is, well, what if that came from e to the 2x? You say, okay, well, that's a great idea. Let's check the derivative to be sure. Okay, so this first step is just kind of a guess. Based off of our understanding, the derivative of e to the 2x is e to the 2x. The derivative of x to the fourth is x to the third. Okay. So now we're going to check, and so we're going to go dy dx, and when we do that, remember that it'll become e to the u, right? So the derivative of e to the u is e to the u, so that would be e to the 2x, but then we have to multiply by the derivative of u, which is 2. So we end up getting 2e to the 2x. Now remember, I want to be able to take the derivative. I want to be able to take the derivative of this to give me the original. Now that means I don't want the 2 in front. So how do I get rid of a 2? Well, I multiply it by 1/2. And notice that the 1/2 and the 2 will end up canceling out, and so therefore y equals 1/2 e to the 2x. You can double check that again by taking the derivative. When you take the derivative, it would just be 1/2 times e to the 2x times the derivative of the inside, which is 2, and the 2 and the 1/2 cancel out, leaving you with e to the 2x. So there's your antiderivative, is 1/2 e to the 2x. Okay, so we're not really using any rules other than the derivative rules that we already know. That's one of the beauties of integrals, is that for the most part that's what we're going to do. We're just going to use these straightforward rules. Now the downside is that, well, we're not going to be able to do any integrals other than the ones that we have derivative rules for. Okay, and really this reasoning is the only thing we're going to be able to deal with for now, and that tends to be the problem with integrals in general, but you'll get to that more later. So let's look at this last one, 1 over the square root of x. Now what I'm going to do before I start dealing with that is I'm going to first change it to y equals x to the negative 1/2, right? Because this is 1 over x to the 1/2, and then you bring it up and make it negative. Okay, so y equals x to the negative 1/2. So where did that come from? Well, it should have come from x to the 1/2 power, right? Because just like in this one, when you take the derivative, you subtract 1. So what do I subtract 1 from to get negative 1/2? Well, I subtract it from 1/2. So let's check. So here's my guess. I added 1 to the exponent. So now I'm going to check it. And so I'm going to go dy dx. And I get, bring the 1/2 in front, so I get 1/2 x to the negative 1/2. Now that's almost what I wanted, except there's a 1/2 in front. So how do I get rid of the 1/2? Well, it means that I need to put a 2 in front, right? And if I put the 2 in front, oh, sorry, not there. If I put the 2 in front, that now means that when I pull the 1/2 in front, it's going to cancel out and leave me with the x to the negative 1/2 that it's supposed to. And so therefore I know that y equals 2x to the 1/2. And in each of these situations, this capital Y, uppercase Y, is the antiderivative, the integral. Now this is what we call an indefinite integral, because we're not taking the integral with respect to a specific range like we did in that first video, but hopefully this gives you an idea of what's going on and that we're just doing this. Now the last thing, which I haven't really done here, is that anytime you do an indefinite integral, you should add a c on, and this will be important much later. But the problem is, when I do that derivative, this could have any number added on, right? There could be any constant there, because when I take the derivative, that c is going to go away to leave me with that negative 1/2. So it's just good, even though the antiderivative doesn't technically have that, the integral does. The antiderivative is just the opposite of this, or the antiderivative of this function. The integral itself will actually need that c, because that will become important as we start to actually do some values. Okay, so keep in mind, antiderivative is just the derivative backwards. So think about what it might be, take a guess, and then check it, adjust for anything necessary, and then you'll have your antiderivative. Add on the c at the end just to show that you understand that when you take the integral, that it will have a plus c at the end. As I say, that will become more important in future lessons. All right, well, that's it for today.